What is going on with this graph? So we're going to talk about continuity today in the context of a graph that's going crazy near zero. This is part 20 in our series of understanding real analysis, and this graph, believe it or not, is continuous at every point in its domain. It's continuous at 1, it's continuous at 1/3, it's even continuous at 0.001. Now what happens at 0? Well, the function's not defined at 0, so that could be one answer. But what if we wanted to extend this function so that it were defined at the point 0? Is there a place we could define that function so that the whole graph would be continuous even at that point? Now, if we zoom in a little bit closer to 0, you can see that these peaks that are happening infinitely often, and they're getting closer and closer together. This is because as x goes to 0, 1 over x is getting larger and larger and larger, and so you're getting all of those peaks that are happening with all those multiples of pi over 2 for the sine function. So if we wanted this function to be continuous, because we have all those values at the top that are staying 1, 1, 1, 1, 1 as the function value, that should mean that we need to define f of 0 to be 1. Remember, our definition of continuity says if the inputs are getting really close to 0, then the outputs should be converging to f of 0. So if all the outputs of those points up at the top are up at 1, well then we need to define f of 0 to also be 1. But the same thing is happening with negative 1. We have a sequence of inputs that are converging to 0, but their outputs are staying fixed at negative 1. So by that argument, we would have to define f of 0 to be negative 1. This is a contradiction. There's no way we can do that. So there's no way to extend this function to be a continuous function at 0. This is an example of a function that's continuous but not uniformly continuous. We'll talk about that in the coming weeks, but for now, it's just a pretty cool example. In a very similar way, we could study, say, this function up here and ask if it were continuous at the number 2. And I'll let you put your thoughts in the comments. Can you find a sequence of inputs that are converging to 2 such that the outputs do not converge to f of 2?